Okay, in this video we're going to take a look at projectile motion, and look at how it relates to free fall and objects in orbit. Okay, so we know that if a person were to throw a ball and they throw it horizontally, it's going to go for a while and then curve and hit the ground. Now, if they throw it harder, it may go further down range, but it's still going to curve and hit the ground. But what if they throw it much harder, just as hard as they possibly can, it's still going to go along a curved path and strike the ground. Well, if that person were to be able to throw it hard enough, and of course if there weren't mountains in the way, and they throw it, it's going to follow a curved path, but if they throw it fast enough, that curved path will match the curvature of the Earth. Now the object is still falling toward the Earth, but it's just going down range so fast that its curve never intersects the Earth. This is what we refer to as orbit. So the astronauts in, say, the space shuttle or the International Space Station, they're actually falling around the Earth over and over and over. So they experience weightlessness not because there is no gravity there, but they're experiencing weightlessness because they're in free fall. And if they want to come home, well, they just simply slow down a little bit, and the curve then would intersect the Earth. So that's how an object stays in orbit, and that's how an object gives up its orbit and comes home. Now, consequently, if the object is going too fast, well, then it would climb to a higher orbit, and perhaps if it was going fast enough, it might actually leave orbit. And this is the way the astronauts traveled to the moon. They went around the Earth a couple times. They changed the shape of their orbit. They fired rockets, and they got going really fast. And instead of falling back around the Earth, they began to travel on toward the moon. Now, speaking of that, if you are going round and around the Earth, then your orbital speed is somewhere in the neighborhood of 8 kilometers per second, which is an incredible rate of speed. That's on the order of somewhere around 17,500 miles per, not miles per second, miles per hour. Let's put it that way, mph. Or it's round about 5 miles per second. So if you're in orbit around the Earth, to stay out there and go round and around and around, you have to be traveling round about 17,500 miles per hour or 8 kilometers per second. Now, what's causing you to have to go so fast? Well, it's the mass of the Earth. So if you were to be traveling around the moon, which has much less mass than the Earth, then you don't have to go as fast, because the moon is not pulling on you. In other words, think about if you were throwing the ball. Because the ball that you're throwing is not under as much acceleration, if you throw it, it's going to go further downrange. What's making it curve like this is the acceleration due to gravity of the Earth. But if you were on the moon and you threw something, because the acceleration of its gravity is much less, you could throw it much farther. So where a human can't throw a ball fast enough for it to get in orbit on the Earth or not even come close, it would come much closer on the moon, because you don't have to be going as fast. Now, obviously, a person can't throw a ball on the moon fast enough for it to go into orbit either, but it's much less than the 8 kilometers per second. Again, not because of the size, but because it has less mass, which means it has less gravity.